Hello, the Darkness344 here, and in today's video I'll be doing a brief showcase of this binary up-down ripple counter that I designed. So this counter can of course count up in binary, as you can see, and it can also count down in binary, admittedly a lot slower, as you can see, and we also have some transition states which I'll come to in a minute. So 2 and then 1. And then of course we also have a reset button, so we can reset the counter to 0. So there's some pros and cons to this counter, and I'll be basically speaking about them and just saying why you might want to use this counter and why you might not. And of course in the next video I'll be basically doing a quick tutorial of how to make one of these, and also of course there'll be a world download in the description of that video. But for now, let's get into the pros and cons. So to first understand some of the disadvantages to this design, we need to understand how a counter actually works. So over here I have a kind of complex setup. It's just a bit kind of hard to understand. I could have done a bit of a simpler one. But we have two T flip-flops, one here and one over here. So there are two types of T flip-flops, well, two main types in Minecraft, and you have a clock-based one, which we can build like this, and when we give in a pulse, a brief pulse it has to be, we can't have a continuous pulse or else it'll clock, it'll just act as a clock. We have to give it a brief pulse, and we can change the state of the clock to a 1 or a 0. So this is the first type of T flip-flop. However, it does come with the disadvantage that we can't exactly tell what state this clock is in, unlike a SR latch based T flip-flop. And the other disadvantage is that you have to have a pulse generator to actually generate a pulse. Okay, this is a bad design. Let's go this side instead. You have a pulse generator like this, because as you can see, you can use a pulse generator like that, but if you don't have a pulse generator and use a long pulse, the clock will work as a clock, so we don't want to do something like this. So over here I have a basic setup. I've just basically spread this design a bit out so I can explain it a bit easier. So over here we have a 2-bit counter, and each of these counters use a T flip-flop in them. And the way this counter passes a carry into the next counter is it takes the inverted state of the output and just puts it right into the next T flip-flop. So of course we have this circuit over here as well, which is basically a pulse generator because we are using clock-based T flip-flops. So as you can see, we have a 1 and a 0, so 1 in binary. Then we have 2, so 0, 1, and of course this is our least significant bit, this is our most significant bit, so 2, 3, and then it should go back down to 0. So fairly simple, and the basic concept is quite simple, and of course you can make them a bit more compact like this, and so with your the pulse generator circuit here, feeding right back into this. And this design over here that I've made makes it even more compact by using comparators for the repeater lock circuit. So yeah, now on to the next disadvantage, which is the actual T flip-flop design over here. So this is a clock-based T flip-flop, and I've kind of explained that of course with the runaway, but compared to say a latch-based design where we use like a SR latch for instance, so we can set and reset, we can't actually set or reset this. We can only provide a pulse in. For instance, the reason you'd have this really is, say we wanted to reset this latch. Well, if it's a 1, well, we could just pulse it right to a 0. But the problem is if we have multiple latches, some could be 1s and 0s, and if we send one pulse signal to all of them, any that are 0 will become a 1, as you can see, and any that are 1 will become a 0. where on a, say, a set reset latch based design, if we send a reset signal, it'll reset all the latches. So it doesn't matter if they're a 1 or a 0, so it could be a 1, and we set it to 0. You can hit the reset time as many times as you want, and it will always set the T flip-flop to a 0 because it's based on a set reset latch. So yeah, that's basically a problem with this clock-based circuit, and it means, oh, I'm stuck in something, it means in this design over here, when we actually reset our circuit, we have a pulse out, of course, but that doesn't matter too much. The main problem is that we are having to set all of these to a 1 with this repeater over here. Then we have to tell the latch to unlock this repeater, then lock it again, so we can put in a determined state into all these digits. So for instance, if it's a 0, let's just enable this over here. So it turns this into a 1, which also hits this repeater over here, and also unlocks this repeater over here into a 1, and then we turn it off. There's a bit of delay in this signal to this signal, so this one will turn off first, which means this repeater will always be locked on a 1 because there's always a 1 being passed in. However, the problem with that, it also means that you have to, for your reset timing, it takes a bit longer to reset. You can't just put in a 1 tick pulse, you have to put in a slightly longer pulse, and that's kind of annoying. So now on to the pros. The first advantage is admittedly also because of this clock-based design. So while a SR latch design is better, it can also be slightly larger than this clock-based design, and someone's probably going to find a video out there or a design out there and prove me wrong and find a design that's more compact than this one and works faster using a latch. However, I've got this fairly compact, this design. So we have 1, 2, 3, 4, 5, 6, 7. So it's 8 blocks by 4 blocks. So that's a fairly, and of course by 2 blocks per lamp. So it's a fairly compact design. And of course you can count up, you can count down slowly, and you can also reset. So that is why this clock-based design is fairly decent. I've used repeater locking for the clock, and I've used a comparator going into the repeater, so I can actually power it from both sides. So if I trigger this comparator here, it will unlock this repeater, and if I trigger this repeater here, it will unlock this repeater, of course going through the same comparator. And in these barrels I just have random items and shovels. I would have rather used a redstone block or something, but that would have interfered with this redstone, and it might have just made the design a bit bigger, so I just used barrels instead. So that's basically the main pro of this design, that it's a lot smaller and more compact. But the other one is, of course, it's fairly simple to build. The concept's really simple. So this is a very simple design that just counts up, and it's, well, I think we power it here. As you can see, the concept is extremely simple, and it's super easy to make a counter like this, because all we're doing is we can pass this torch into this block, then take the invert state of whatever this is because of that torch. We can take this, and then we can pass this through a pulse generator and put it into the next counter over here. So it's an extremely simple design, and I basically made this first, then made a few tweaks to make it into this design over here and make it a bit more compact with the reset feature and unfortunately the down feature as well. So this counter, the down feature actually was originally meant to be my reset feature. As you can see, it hooks up to both this one and this block. However, I didn't do the timings properly. I should have actually had a repeater in between these two redstone, so that the signal would stay longer here than here. However, this has while I was making this actually had the weird side effect of it actually working as a down counter. So it does work as a down counter for some weird reason. It is admittedly slow because of the ripple, but it does mean we can count up, and we can also count down fairly simply. And of course we have the reset built in. But yeah, so it's a weird additional bonus to this counter design. So I guess you might want a counter that can count both up and down. I'm not sure if there's any tutorials on that. So yeah, the next video will definitely be a tutorial on this counter. And I'll also kind of show off how I basically made it and how the components kind of work out a bit better. So yeah, I hope you liked this video. And before I go, you may have been seeing some stuff in the background. And yes, this counter, I actually made it for something that will, a big project coming up. So yeah, please like and subscribe, and I'm out.